Welcome to another Designer Getting Started video. In today's video, we are going to look at Exercise 4, Advanced Direct Modeling from the Designer Training Guide. You will be able to follow along using the training guide starting on page 36. Here we are starting with a new session of Designer. If you already have Designer open, click on File, New to start a new part. To start our part off, go to the Solids tab and click Cylinder. In the option ribbon, change the filter to Enhanced Pick and change the color to blue. In the option window, set the creation method to Select 3 points, the direction should be automatic, and the Boolean operation set to None. Select the work plane marker to place the cylinder center. Fill in the modifier with 125 for the radius, then hit Enter. Start to pull your cursor downward for the length of the cylinder and type in 5 in the modifier. Hit Enter to create the cylinder. We will now add a second tier to the cylinder. From the Options window, click Unite in the Boolean operation. Select the center snap point of the circle at the bottom of the cylinder to start our second tier. Type in 150 in the modifier for the radius and hit Enter. Again, pull the cursor downward for the length of the cylinder and type in 20 in the modifier. Hit Enter to create the second tier. Now we are going to add a boss for a bolt hole. On the large cylinder, select the quadrant snap point in the x-positive direction. Fill in the modifier with 20 for the radius and press Enter. Pull the cursor downward and select the bottom edge of the large cylinder. This will set the length of the boss at the same depth as the cylinder. To create the hole, in the Options window, change the Boolean operation to Subtract. Select the center snap point of the boss we just created. Fill in the modifier with 8 for the radius and press Enter. Pull the cursor downward and select the bottom edge of the boss to set the depth of the hole. We now want to offset the hole and boss in the x-negative direction. From the Solids tab, select Move. From the Operations window, select the option Move and Move Concentric Faces. In the Transformation section, enter -5 for the x-axis. Select the cylinder wall for the 8 mm radius hole. Right-click to exit the command. To create the rest of the bosses, from the Solids tab, select Rotate Feature. Select the faces of the hole and boss. Do this either by picking directly or by window. For center of rotation, we will use the work plane marker. For the rotation axis, we will use the option ribbon to pick the z-axis. You could also use the z-axis of the active work plane or pick the z-axis of the datum compass. Right-click to confirm the axis, then fill in the modifiers. Calculations can be entered into any modifier. In this case, we want to have 20 bosses total, so in the angle field, enter 360 divided by 20. For options, activate Multiple Copy and 19 for the number of copies. Right-click to confirm. As you know, we can use a right mouse click to exit a command. We can also use the Escape key. Now that we have the base flange created, we can start creating the valve body. From the Solids tab, select Cylinder. From the Options ribbon, change the filter to Circle Center. In the Options window, set the creation method to Select 3 points and the Boolean operation to Unite. Select the center snap point at the bottom of the flange. Type in 100 in the modifier for the radius and hit Enter. Pull the cursor downward for the length of the cylinder and type in 250. Hit Enter to create the first section of the body. To create the next section of the body, pick the center point of the cylinder we just created. We want this section to be 90 degrees to the first section. Click the arrow icon to select direction in the Options window. Now, in the Options ribbon, click on Select X-axis. Right-click to confirm the direction. Type in 100 for the radius in the modifier, then press Enter. Pull the cursor in the negative X direction and type in 450 in the modifier. Hit Enter to create the second section of the body. As we know, we can hit Escape or right mouse button to exit a command. Another way to exit a command is click the red X in the Options window. Now we will connect the two body pieces with a sphere. From the Solids tab, left-click and hold down the arrow under Prism. Move the cursor down to Sphere and release the left-click. In the Options window, set the creation method to Select Position and the Boolean operation to Unite. Select the center point at the bottom of the vertical cylinder to place the center of the sphere. In the Options window, type in 150 for the radius and press Enter. Right-click to create the sphere, then right-click to exit the command. Now we are going to add a radius at the end of the valve body. From the Solids tab, select Blends. On the Options ribbon, change the filter to Single Edge, then pick the edge of the 100 mm radius. We want the radius of this edge to be the same radius as the boss on the flange. There is an option that will allow us to pick that radius to get the measurement without having to remember what it is. Left-click the Measurement menu from the label. From the Measurement menu, select Segment Length or Circle Arc Radius. Select an edge of one of the bosses. Right-click to confirm, then right-click to exit the command. Now that the valve body is created, we can create the handle. From the Solids tab, select Cylinder. On the Options ribbon, change the color to orange. In the Options window, set the creation method to Select 3 points and the Boolean operation to None. Select the center point at the end of the valve body. I need to adjust my direction here so that the handle shaft runs the same direction as the valve body. To do that, click on the arrow icon next to Direction in the Options window. Select X-axis is already selected in the Options ribbon, so we just need to right-click to confirm. Type 20 in the modifier for the radius and press Enter. Now that we are going in the correct direction, type in 200 for the height and press Enter. Right-click or press Escape to exit the command. Now we need to adjust the position of the handle shaft. From the Designer tab, click Translate. From the Options window, select Incremental and Move Elements. Using the incremental option will allow us to enter a value for the translation. Select the cylinder. Type in 100 in the modifier for the X-axis to move the cylinder into the valve body. I chose to enter the value in the label. but the value could have also been entered in the options window. Right-click to confirm, then right-click or escape to exit the command. Now, we will put a pocket into the handle shaft for an anti-rotate key. From the Solids tab, click Cuboid. In the Options window, set Creation Method to Select 3 points, the Application Point to Y-axis Edge Center, and the Boolean Operation to Subtract. On the Options ribbon, set the filter to Enhanced Pick. Place the cursor over the top quadrant on the cylinder and wait a couple of seconds. This creates a special snap point to work from. Move the cursor along the cylinder to see a construction line and modifier. Type 15 into the modifier. This sets a start point of our cuboid 15 mm from the edge of the cylinder. From the Options ribbon, change the filter to Sliding. I find it easier to zoom out and have the cursor off of the part to get the cuboid going the direction I want. Type in 30 in the modifier for the length, then press Tab to jump to the next modifier. Type in 10 for the width and press Enter. Pull the cursor downward and type in 5 for the depth. Press Enter to create the pocket. Right-click or escape to exit the command. Now to add a radius at each end of the pocket. From the Solids tab, click Blends. On the Options ribbon, select Edges Away from Face for the filter. Pick the bottom face of the pocket. We want the radii to be half the width of the slot so it produces a full rounded end. Select the measurement menu from the label. Select Y distance from the context menu. Using this option allows us to pick 2 points but only return the Y distance. In the Options ribbon, set the filter to Enhanced Pick. Select the center snap point on the edge of the slot, then pick the end snap point. Right mouse click to confirm, then right mouse or escape to exit the command. Now, we will use the bottom of the pocket to create the key. From the Solids tab, click Extrude. From the Options ribbon, set the environment to Faces and the color to pink. The environments allow us to limit what we can select. Using the Faces environment will limit our selection to only faces of a solid or surfaces. Select the bottom face of the pocket. From the Options window, fill in the modifiers. First distance, 10. Automatic solution unchecked. Boolean operation set to none. Right mouse to confirm, then right mouse or escape to exit the command. As we see here, the key held on to the original color for some of the faces of the solid. We can correct this using the Edit Properties command. From the ribbon, click Edit Properties, then select the element's environment. Pick the key, then click on the cube for Reset Color. Right-click to confirm, then right-click to exit the command. We can see that the key is now all the same color. Now we can start creating the handle. From the Solids tab, click Cylinder. Make sure our filter is set to Enhanced Pick and change the color to purple. Place the cursor over the 20 mm arc to highlight the center point. In the marker that appears, type in -20, 0, 0, and hit Enter. By doing this, we push the start point of our cylinder 20 millimeters off the edge of the shaft. Our direction is not correct. To get the correct direction, click on the direction arrow in the Options window. Then click Select X-axis in the Options ribbon and right-click to confirm. In the Options window, fill in the modifiers. 40 for radius, 70 for height, and set the Boolean operation to None. Right-click to confirm, and right-click or Escape to exit the command. Now we will use a Boolean operation to create the keyway in the handle. From the Solids tab, select Boolean. Click the purple cylinder as the target body. Activate the Multi-Select filter in the Options ribbon. To make selecting the key and shaft easier, we can use the Layer window. Expand the assembly tree and slide the cursor over the different layers. As you slide the cursor over the layers, the corresponding solid will highlight in the graphics area. Find the layer for our handle cylinder and uncheck it to turn it off. Go back to the Operation tab and select the shaft and key. In the Option window, set the Boolean operation to Subtract and the attributes to Retain Tool Bodies. Activating the Retain Tool Bodies will allow us to subtract them from the handle cylinder without losing the key and shaft. Right-click to confirm, then right-click to exit the command. Now we can go back to the Layer window and turn off the rest of the solid layers by unchecking the box next to Layer 0, then check the tick box to turn on the layer for our handle cylinder. Now only our handle is visible. Look at the handle cylinder and we can see the area we created after subtracting the shaft and key. We can adjust the keyway so it works with the key we created. From the Solids tab, select Move. Select the radius at the back of the keyway. In the Options window, select Move and uncheck the Move Adjacent Faces tick box. Fill in the X-axis modifier or use the slider to extend the slot 10 millimeters in the negative direction. Right-click to confirm. Using the same command, we will extend the front of the keyway. Select the radius at the front of the keyway, then use the slider to pull the keyway outside of the handle cylinder. Right-click to confirm, then right-click or Escape to exit the command. Now we can create the hand wheel for the handle. From the Designer tab, click Create. We will now create a new work plane on the face of the handle cylinder. Select the center of the 40 millimeter radius, then right-click to create the work plane. Right-click to confirm. Right-click or Escape to exit the command. For the hand wheel, we will create a torus. From the Solids tab, left-click and hold on the arrow under Prism, slide the cursor down, and release on torus. With our filter on Enhanced Pick, place the cursor over the 40 millimeter radius to highlight the center of the circle. Type 0, 0, 20 in the modifier and press Enter. Pull the cursor outwards and type 160 in the modifier for the major radius and press Enter. For the minor radius, type 10 in the modifier and press Enter. Right-click to confirm, then right-click or Escape to exit the command. Now we need to create the spokes for the hand wheel. From the bottom toolbar, click the work plane icon to set it to WPL XY top. From the Wireframe tab, select Lines. In the Options window, select Retain Last. Place the cursor over the workplane marker. Type 0, 0, -10 in the modifier and press Enter. Using the HUD, change to a front view. Fill in the modifier with 100 for the length of the line in the X positive direction and press Enter. Fill in the modifier with 30 for the length of the line in the Z positive direction and press Enter. Fill in the modifier with 60 for the length of the line in the X positive direction and press Enter. Right-click to confirm, then right-click or Escape to exit the command. We will now use the Circles command to create fillets on the spoke. From the Wireframe tab, select Circles. In the Options ribbon, select the Elements environment. Select the bottom horizontal line and then the vertical line. Pull the cursor outward and type in 15 for the radius in the modifier and press Enter. Next, select the vertical line and then the upper horizontal line. Pull the cursor outward and type in 15 for the radius in the modifier and press Enter. Right-click to confirm, then right-click or Escape to exit the command. From the Wireframe tab, select Trim. Pick the sections of wireframe to be removed to trim the spoke. Right-click or Escape to exit the command. Now we will turn the wireframe into a solid spoke for the hand wheel. On the Surfaces tab, select Piped. On the Options ribbon, select the Elements environment. Window select the wireframe elements. From the Options window, set the Start Radius modifier to 8 and select Create a Solid. Right-click to confirm, then right-click or Escape to exit the command. The spoke is created with multiple solids because we selected multiple wireframe elements. This will be corrected in a bit. Now, we will rotate the spoke to create the rest of the spokes we need. From the Designer tab, left-click and hold on the arrow below Translate, slide the cursor down, and release on Rotate. Window select the piped solids. Select the workplane marker as the center of rotation. From the Options ribbon, click Select Z-axis, then right-click to confirm the rotation axis. In the Options window, select Multiple Copy, set the angle to 60, and the number of copies to 5. Right-click to confirm, then right-click or Escape to exit the command. All of the pieces of the hand wheel are created. Now we can join them together. From the Solids tab, select Boolean. In the Options window, set the Boolean operation to Unite. Pick any element of the wheel as the target body, then select the rest of the solids as the tool bodies. In the Options window, uncheck the Retain Tool Bodies tick box. Right-click to confirm, then right-click or Escape to exit the command. Now, let's use the Layer window to turn off the wireframe we used to construct the spoke. Go to the Layer window, click on the tick box for Layer 0 to turn on all of the solids. Then click the tick box for wireframe to uncheck it. This will turn off the wireframe layer. Go to the Workplane Manager window and double-click the absolute workplane to activate it. The green dot indicates the active workplane. From the HUD, or using the F2 key, change the view to isometric. Now, we will insert a mounting block for the valve we created. The mounting block is included in the file package. Once inserted, we will do some work on the block to learn some additional commands. From the bottom toolbar, make sure the workplane is set to absolute XY top. Go to the File tab, then Insert. Select the file 4A, Advanced Direct Modeling, then click Insert. On the pop-up menu, select Insert by Node Name. We want to place the inserted solid on the workplane marker. We will make this easier by using Layer Management. Using the same method we learned earlier, we will turn off the layers for all the solids and turn on the layer for the newly inserted block. Rotate the view around so we can see the underside of the block and click on the absolute workplane marker to place the block. Rotate the view around so we can see the underside of the block. This block has some posts that fit in the clearance holes of the valve flange. We are going to change these posts into bolt holes. From the Solids tab, select Edit Radius. On the Options ribbon, select Multi-Select. Select all the cylindrical faces of the posts, then right-click. From the Options window, change the radius modifier to 6 and click Change Radius. Right-click to confirm, then right-click or Escape to exit the command. We have adjusted the size, and now we can turn them into holes. From the Solids tab, select Move. On the Options ribbon, select Matching Faces. Pick the top of any one of the posts. The Matching Faces option selects all surfaces that are on the same plane as the surface selected. This has selected the top face of the block, which we don't want to include in this operation. In the Options window, click through the Elements to Move list to highlight the unwanted surface. Once we find it, click the trash can icon to remove the surface from the list. In the Options window, select Extrude. Left-click, then drag the Z slider until the top face of the post sits flush with the face. In the Options window for the Z transformation, we see 20. This is the amount that we have just moved the post. We can do math in the field to complete the move. After the 20, type plus 30. Click the check mark to complete the command. As we have done throughout this lesson, we could right-click to confirm the command. The check mark is just another way of doing the same thing. We will now offset the outer ring so that our valve fits easily into the block. We are still in the Move command, so we just need to adjust the filter. In the Options ribbon, select Tangent Faces and Multi-Select. In the lower right corner, set the max angular deviation to 85 degrees. Select any face in the outer ring. With the options we set in the Option ribbon, all the faces of the outer ring will be selected. We want to do the inner ring as well, so select that face too. Right-click to confirm our selections. In the Options window, select Offset Reblend, uncheck move concentric faces, and enter a distance of 0.5. Right-click to confirm, then right-click or escape to exit the command. From the Layers window, turn on the layers for all the solids from the structure tree. The valve assembly and mounting block are now complete. As always, we hope you found this Getting Started video helpful and would like to encourage you to explore all the features Designer has to offer.